Assalamu alaikum dear students. Today we are going to start our numericals of unit 7. So the first numerical is a numerical number 5 on a book page number 196. You can see on a 196 page question number 5 it's also on your screen that our question is a block of fully immersed in water. Before immersion the block weight 30 Newton and while immersions its apparent weight is found to be 25 Newton. Calculate number A the upthrust on the block, number B the weight of the water displaced, C the volume of water displaced, D the volume of block, and the E is the density of the block. Now we are going to start our numerical number 5 and the given data is weight in air W equals to 30 Newton, weight in water WB equals to 25 Newton, density of water equals to 1000 kilogram per meter cube, gravitational acceleration we know that equals to 9.8 meter per second square. Now the required data, the A is given to you that upthrust bind force on block FB equals to question mark and the weight of the water displaced equals to question mark, volume of water displaced equals to question mark, volume of block object equals to question mark, density of block is the question mark. We are going to find these five unknown values. The formula is the first one is FB equals to WA minus WB and the second FB equals to a W. Now the WW is the weight of the displaced water. Now the third is the W by FB equals to a mu naught divided by mu B, and the fourth is a density naught equals to a mass by volume. Look at in the block that a density equals to mass by volume. Okay. Now the fifth one is the density volume equals to a mass by density, and you can see that as density equals to m by v. By rearranging, if we are going to find the value of volume, so we are going to be a cross multiplication, the W volume equals to a mass by density. Since mass equals to W by G, how you can write that m equals to W by G, that we know that W equals to mg, and if I am going to find the value of m, divide both sides by G and m equals to W by G, and the volume displaced equals to a volume by Archimedes principle. Now the solution, we are going to find out the solution. Number 1, first we are finding a binding force, upthrust force by using formula 1 FB equals to a WA minus WB, putting the value FB equal to a 30 minus 25 and the answers comes a 5 Newton. This is the upthrust force. Now the second one is, now we are finding the weight of water displaced. WW displaced equals to question mark. According to Archimedes principles, the weight of the water displaced bind force is bind force or upthrust force by using formula number 2 FB equals to a W equals to FB, so the FB equals to a 5 Newton. So W of weight of water also is the 5 Newton. Now the C number that, now we are finding a density of the block. Now by we are using a formula, we have used this one formula in the previous questions assignments also, that a W by FB equals to a density of the object divided by density of the block. By rearranging the terms, that a density of object equals to a W by FB into a density of the block. By putting the values, we are going to put a value 30 by 5 multiply by 1000 kilogram per meter cube. Here we are going to multiply and divide, the answers comes a 6 into 1000 and the 6000 is the answer. The density of the block is a 6000. Now we are finding a water. So a V equals to a m by density, mass by density. So first we are finding a mass. We don't have the value of mass, so we are first finding a mass, m equals to W by G, putting the value 5 by 9.8, the mass comes a 0.51 kilogram. Now put the value in a mass. In equation 1 we are going to find put the value in equation 1 by putting the value volume equals to a 0.51 divided by thousands, and the answers comes up 5 multiplied by 10 raised to the power minus 4 meter cube. Volume of water displaced V equals to 5 multiplied by 10 raised to the power of minus 4 meter cube. Now we are finding the block of volume of block. According to Archimedes principles, volume of object equals to a volume of water displaced. By using a formula V naught equals to VW or VW equals to V naught, Now we are finding, now as we know that the volume of water displaced VW equals to a 5 multiplied by 10 raised to the power minus 4 meter cubes, as V naught equals to a 5 multiplied by 10 raised to the power minus 4 meter cube. So the results come up. Upthrust force, bind force F equals to a 5 Newton. Weight of water displaced comes a 5 Newton. Density of blocks comes a 6000 kilogram per meter cube. Volume of water displaced equals to a 5 multiplied by 10 raised to the power minus 4 meter cube, and the volume of the block comes to be a 5 multiplied by 10 raised to the power minus 4 meter cube. Now we are start a numerical number 6. When a weight of 30 Newton is hung for a wire of original length 2.0 meter, its new length becomes a 2.20 meter. Calculate the force constant for the wire if the elastic limit is not exceeded. So the given data is force is 30 Newton, length L1 is a 2.0 meter. It's original length, and when you change that, a new length comes a L2 equals to a 2.20 meter new length. Okay, extension X L2 minus L1, and it comes a 2.20 meter minus 2.0 meter, and the extension X values comes a 0.2 meter. Required that a force constant K. We are going to find out the K formula according to the Hooke's law. F equals to minus Kx. We know that solution F equals to minus Kx. By rearranging the terms, that we are going to find the value of K. Now the K equals to minus F by X. Force spring constants cannot be negative, so K equals to F by X, putting the value 30 by 0.2 meter. So the K comes a 150 Newton per meter. Results that a force constant K equals to a 150 Newton per meter. Now we are going to start a numerical number 7 as 80 centimeter long, 1.0 millimeter diameter steel guitar string must be tightened to a tension of 2000 Newton by turning the turning screws. How much is the string stretched? Now the given data is given to you that a force tension F equals to a 2000 and length L equals to a 80 centimeter. The value is given into a centimeter. Converted into a meter, 80 by thousands, it comes a 0.80 meter. Now the diameter D equals to a 1.0 millimeter, and divided by thousands to convert into a meter comes a 0.001 meter. So the diameter comes a 0.001 meter. Radius R by D2. Put the value that a D value is a 0.001 meter divided by a 2, and it comes a 0.0005 meter. So the radius R comes a 5 into 10 raised to power minus 4 meter. Young modulus of steel Y equals to a 20 multiplied by 10 raised to the power 10 Pascal. Okay, the value is given to you that we are also write a 20 multiplied by 10 raised to power 10 Newton per meter square, the same, not a difference of the Pascal or a meter per Newton by meter square. Pi value is a 3.14. We know that area A equals to a pi r square. Now putting the value that A equals to 3.14 multiplied by 5 multiplied by 10 raised to the power minus 4 meter whole square. First we are going to solve the square. The answers comes at 2.5 multiplied by 10 raised to the power minus 7 meter square. And 3.14 comes like the same. Multiply these two and the answers comes 7.85 multiplied by 10 raised to the power minus 7 meter square. Required data is extension X is the unknown. Formula आपके पास है young modulus equals to F into L by A into X. Now solution and put the value. First we are going to rearrange because we are going to find the X value. X equals to F into L by A into Y. Putting the value and put value 2000 multiplied by 0.8 meter divided by 7.85 multiplied by 10 raised to the power 7 meter square into 20 into 10 raised to the power 10 Newton per meter square. Now the 1600 divided by 157 thousands divided, and the answers comes X equals to a 0.01 meter. So the X comes a 1 multiplied by 10 raised to the power minus 2 meter, and the X equals to a 1 centimeter. So the results comes x equals to a 1 centimeter. Okay, we have done these three numericals and the numericals is finished. Allah Hafiz.